Alright guys, Mr. Milton here going through the practice quiz. Follow along. Feel free to skip ahead to the problems that you had issues with. For our first problem, they tell us that PQ is a chord for both M and N, and that MN is 60, and the radius is 34 meters. Okay, so we want to find out how long PQ is. The first thing I noticed is that, hey, they told us what our radius is. Let me use that here and say that this is 34. Okay, and because as I'm looking through this, because this is the diameter that goes through the chord, or radius that goes through the chord, then I know it's perpendicular, so I know this is 90 degrees. The troubling, or I guess the difficult thing with this is how to distribute this 60. They told us that MN is 60, but how much does this go? Okay, the way that we can figure this out is through one of our theorems that we talked about in 10.4, is that if a chord is congruent, then it is equidistant from the center. So because PQ is in both M and N, circle M and circle N, must mean it's congruent, because it's PQ is equal to PQ. So that must mean it's equidistant from the centers, M and N. So that means that we can find out that MX and XN are both 30. This helps us out because now we can use our Pythagorean theorem to find out what PX is. So our Pythagorean theorem is 34, again 90, 30, and so we can do our math. 34 squared equals 30 squared plus x squared. Okay, and so we find out that this is 900. 34 squared is 1,156. Okay, and so we find out that x squared is 256 and x is 16. So what that tells us is that this is 16. Okay, saying that this would be 16, so PQ is 16 plus 16, or 32 units. What is it, meters? Okay. Alright, for number 2, make sure sound's on. For number 2, notice that we are given, we're trying to find x, which is a radius. Okay, it's not drawn in a very strategic place, but it is a radius, and we know that radii and the circles are all congruent, so we're just going to draw another radius here as x. Kind of get to use the same theorem that we used in the previous problem here. This whole chord is 30 because this is perpendicular to the chord through the center, then we know it bisects it, so this must be 15. Again, we're using Pythagorean's theorem. 9 squared plus 15 squared should equal x squared. 81 plus 225, right, equals x squared. So x squared is 306. Okay. Notice again, I could reduce this, but the question is asking us to find the area of the circle. In order to find area is pi radius squared. Okay. So we already know what the radius squared is. The radius squared is 306, right? Because that's x squared. So our answer, 306 pi. Alright, numbers 3 and 4, looking at inscribed angles. Always important for these problems to realize what angles you have and what arcs correspond with them. So for Z, notice that Z inscribes 170. So 170 divided by 2 should give us 85. Okay, they told us that this arc is 170. They told us that this arc is 90. And we know that the entire circle should be 360. So 170 plus 90 is 260. That leaves us with 100 here. Okay, notice that that 100 is inscribed by y. So y should be half of that, 50. Okay, we can do some more inscribed angles math there if we wanted to, and see that x inscribes 90, so x is 45. Or because it was a triangle, we could say, hey, all three of these angles need to add up to 180, and that is still the case. Okay, so a way to double check our answers. Number 4, pretty sure we've seen this problem before. Same thought process here. 54 is the inscribed angle, means the arc here must be 108. Okay, notice that they gave us a triangle, and in this triangle they told us, hey, this is an isosceles triangle, right, by those markings. And so since this is 54 it should be 180 minus 54 divided by 2. Divided by 2. Oops. 180 minus 54 divided by 2. 63. So these angles here are 63 degrees. Okay, so y is 63 degrees. Oops, I kind of talked about this arc, but I didn't find z. So the inscribed angle here is 108. Since it's a tangent line, and the inscribed angle z should be half of that arc, which is 54. Okay. Again, there's a couple different ways we can find x. One of them is that because it's a straight angle, adds up to 180. So we've got 54 plus 63 plus something equals 180. 63 plus 54, 180 minus that answer, 117. X should be 63. Okay. Alright, still dealing with inscribed angles here at the bottom. For this, we are given 2 of the arcs. Again, we know that all 3 of the arcs should add up to 360. So add these 2 together, 117 plus 121, subtract from 360, and we get this arc as 122 degrees here. Okay, so now as we find these angles, we will use the equation because they happen on the outside, 1/2 x minus y, and that should give us the measure of those angles. And so for x, x will equal 1/2, I should say x will equal 1/2 this arc, this back arc, which is 117 plus 121, which gives us 238 minus 122. Okay, and so that's 116. So x is 1/2 of 116, or 58. We'll do the same thing for y. Y here, 1/2 of this big arc here, which is 239, minus 121, which gives us 118. Okay, so y equals half of 118, which is 59. And then we'll do the same thing for z. 1/2 of 122 plus 121 is 243, minus 117, and that gave us 126. So z is 1/2 of 126, which ends up being 63. Okay. Alright. On to the back side, more angle stuff. Notice here on this first question that the angle happens from the intersection of chords inside of the circle, and so our equation changes a little bit. We can find x, because it's inside, as the sum of the 2 arcs. So 88 plus 86, half of the sum, which would give us 87. Okay. Notice for number 7, we're not finding an angle, we're finding a segment length. Okay, the ratio between the distances to the edge of the circle should be constant, and so we should have 8 times 2.5 equals 2 times x, so that's 16. 20 equals 2x, divide by 2, x will equal 10. Okay. Number 8, again, the distance from the edge of the circle, so 5 times 15 should equal 4 times x plus 4. Okay, and so that gives us 75 equals 4x plus 16. Subtract 16, that gives us 59. 4x, divide 59 by 4x. Do that with a calculator. 59 divided by 4, 14.75. So x is 14.75 in that case. Okay, on number 9, similar to the last problem on the first side, we have an angle that's made outside. and we have two arcs inside. So we have the x should equal half of the difference between 150 and 60. We subtract those two, that gives us 90. So half of 90 is 45. Number 10, we have a tangent and a chord. So what we see here is that we have x squared, because it only touches the circle in one place, so the distance x times x equals 6 times to the other edge 13.5. Right. So 6 times 13.5 gives us 81. X squared equals 81. That must mean that x is 9. Oops, sorry, let me go back up here and correct something. Okay, the directions here say to the nearest tenth, so I shouldn't have said 14.75. I should have said 14.8. Okay, make sure you read directions. Alright, number 11, final question for this practice quiz. Same situation as we've seen a few times already. 56 is the angle that's made outside of the circle. It should be half of the measure of the arcs that are intercepted here. 170 minus x. Okay, so now I'm just solving for x. I multiply both sides by 2, get 112. 170 minus x. Subtract 70 from both sides. 170 from both sides. We should get negative 58 equals negative x, and so x is positive 58. Okay, and so there's our answers. Alright, so there's your walkthrough of the practice quiz. Check that out, and hopefully that helps you prepare for your test. See ya.